Hello everyone, welcome to my channel. I am Ishita, your physics mate. Well, from the thumbnail, I think you got to understand that our today's video is going to be on the topic decimal to binary conversion. Well, here I am going to introduce a trick by which you can easily convert a decimal number into a binary number and vice versa. And at the last of this video, I am going to share a tips which will be very helpful for you. I think you will enjoy this video, and don't skip the video and watch the video till the end so that you can hear that useful trick. And if you like this video, please share this video with your friends, and please subscribe to my channel for further such videos. And okay, let's get started. Hello and welcome to my channel, your physics mate. Well, from the introduction, you got understand that our today's video is going to be on the topic decimal to binary transformation and vice versa. Well, here I have written the normal way in which we genuinely convert a decimal number to a binary number, that is dividing that decimal number by 2 and then gathering the remainders all together. Okay, so here I have written just a number 19 and dividing it by 2 and gathering the remainders, we got a number 10011 base 2, which is a binary number corresponding to the decimal number 19. But here in this video, we are not going to do that. We are going to do some tips we are going to do some tricks here by which we can easily convert a decimal number to a binary one. So first of all, we need to know what is a binary number. In binary number system, we have only two values, either 0 or 1. That is binary. A binary number can have only two values, either 0 or 1. As it has only two values, it has a base of 2. Okay. But in case of a decimal number, we can have any values between 0 to 9. We can have any values between 0 to 9. As there is total 10 numbers between 0 to 9, we have a base of 10 in case of a decimal number. So a decimal number has a base 10 and a binary number has a base 1. Hence, when we write a decimal number, we write base 10 at the rightmost down corner or at the suffix of decimal number, or for writing a binary number, we write a base of 2. In this way, we can recognize which number is a decimal number and which one is a binary number. Always remember that 101 can be a decimal number, can also be a binary number, because 0 and 1 are also the values of a decimal number 2. So, if we write 10 in the base, it becomes a decimal number, and instead of 10, if we write here 2, it will become a binary number. So, always very give some importance here in the base. Okay, always look at it, that which is the base, it is 2 or it is 10. Okay, anyways, so now the main topic of our today's video, it was the basic information or introduction which you need to know to just start this video. Now suppose I am writing here a number, a binary number. Okay, 1011. Base, obviously base is very important. I am writing here a base 2, so you can recognize it is a binary number. Now always remember that each of the 0 and 1s, that is this one, this 0, this one, these each of them are called a bit. So each number which just makes a binary number, right? Each of the values of a binary number or each of the numbers inside a binary number is called a bit. Okay. Now a 8-bit grouping is called a byte. If I write 10111010, so how many numbers here? we have 8 beats here, right? This grouping of 8 beats are called byte. Okay, so I think you are now understood that which is a beat and what is a byte. Now, suppose we are taking a 4-beat number, suppose which I have written before 1011 base 2. Okay, now each of the numbers has a finite position. When we give it a number, if we just mark the position, we always try to mark from the rightmost position, because the rightmost position has the minimal weightage and the leftmost position has the maximum weightage. Now you are wondering that what is weightage, right? So I will write here we will explain in this video that. Okay, so I am writing a 1 0 1 1. I have written 4 beats here, right? 1 0 1 1. Now this one has a position of 0. This is the first position, right? We always mark the position from the rightmost side. So this one has the position of 0 in the rightmost position. Just the left one, just the adjacent left one has a position of 1. Just its adjacent left one has a position of 2, and this last one has the position of 3. Okay. Similarly, if we consider this byte, if we mark the positions, okay, this 0 has a position of 0, it has a position of 1, 2, 3, 4, 5, 6, 7. So I am just marking their positions, okay, and I am just giving their positions a finite number. Now, as the base is 2 for a binary number, whenever we are going to give it a weightage means the base to the power position ranking. Base to the power position ranking. What is the base? 2. And 2 to the power position ranking, suppose I am giving this one. I want to know what is the weightage of this one, which is at the position of 1 also. So I am going to write the base, and to the power of the base I am going to write the position ranking, that is 1, right? So I am writing 2 to the power 1. What does it mean? Of course 2. If I want to write the position of this one, so what will you do? Base, that is 2, and to the power of, what is the position ranking here? Position is 3. So 2 to the power 3, it means 8. Okay. So we got the weightage, right? So in this way, if we write a byte, suppose 1 0 1 1 1 0 1 0, base 2. So what is the weightage of this each value? This one has a 0 position, so 2 to the power 0, it means 1. This one has 1 position, so 2 to the power 1 means 2. This one has a 2 position, so 2 to the power 2 means 4. This one has 3 position, so 2 to the power 3 means 8. This one has 4 positions, so 2 to the power 4 means 16. This one has 5 positions, so 2 to the power 5 means 32. Okay, this one has 6 position, 2 to the power 6 means 64, and finally this one has a 7 position, so 2 to the power 7 means 128, and so on and so forth. We can write this kind of position ranking and weightages for a more long number. Okay, so okay, I am going to write here this matlab, yeah, right here we are just going to do that, and if you want to know much more longer number, you can just add more and more numbers on the leftmost position, and then you can write to the power 8, to the power 9, to the power 10, just taking the positions to the power the base. Okay, so we got the weightages here. If you write for a byte, what are the weightages we got from here? That is 128, 64. Okay, wait a minute. We got the numbers here, right? Like that. It has 128, 64, 32, 16, 8, 4, 2, 1 and 0. Okay, so we are getting the number of the positions just one after another. We need to remember that to make a decimal number. Now you are wondering what I am talking about. So if I write these weightages one after another in this way, you can write this 128, and then it is 64, then it is 32, then it is 16, then it is 8, then it is 4, then it is 2, then it is 1. These are the weightages, right? Suppose you want to make a number, any decimal number. Suppose I am going to write 10. Okay, 10 base 10. So this is not 10 in binary, this is 10 in decimal. Okay, so if I want to write it in binary, it is a decimal form, and I want to write it in binary one. Okay, so what will I do? Construct this 10 with these numbers. Yes, this is the main thing or main trick of this video, or the main part of today's video. Okay, we need to just form a 10 by adding these numbers. Okay, we are going to write 10 by adding these numbers. Now you are wondering, how will we make 10 by adding these numbers? Well, don't worry, I am going to show you how. Here 10 means which one of these numbers, by adding which one of these numbers you can get a 10. What do you think? Of course, this 8 and this 2. 8 and 2 makes a 10, right? Okay, so we have to take a 8, we have to take a 2. So place 1 in these positions and place 0 in the other positions. So we got a number 1, 0, 1, 0, base 2. Isn't it easy? Okay, take one more example. Suppose, now here as we already, if we take only 4 bits, we can easily convert it into a binary number. So we are taking a 4-bit number here. Okay. Instead, suppose we want to make a number which is like take 25 base 10. We want to make it a binary one. Okay. So now add these numbers to make 25. If you want to make it by yourself, then pause the video for some time and try to make it out, and then again see which is the answer. Okay, so here we need to know by adding which numbers we can have a number 25. Okay, so we can take this number, that is 16. Okay, so by adding which numbers means 16, which numbers by adding with 16 we can have 25, that is 9. 9 and 16 makes 25. Now we have to make 9 by the rest of these numbers. So which of them can make a number 9? Obviously 8 plus 1 makes 9, that is 16, 8 and 1 all together makes 25, right? 16 plus 8 plus 1 makes the number 25. So we are going to write 1 in this position. That is for 16 position we are writing 1. For this 8's weightage we are writing 1. For this 1 weightage we are writing 1. And these 2 positions we are writing 0. So what becomes the number? 11001 base 2. Isn't it easy? Okay, take one example more. You have to learn very precisely, okay? Have to learn it. Now, suppose we want to make a more bigger number by this, okay? Suppose we want to make 100 by it, 100 base 10. This is obviously not a binary 100, this is decimal 100, okay? So we have to make 100 by it. Now take which of these numbers can make 100. By adding which of these numbers we can have 100. So we can have a 64, right? 64. We can take 32. 64 plus 32 plus 4. Does it make 100? Plus it. 32 plus 4 makes 36. 36 plus 64 makes 100. So give 1 to this position, that is this position is 1, this position is 1 and this position is 1 and all other positions are 0. So what becomes the number? 1 1 0 0 1 0 0 base 2. Isn't it quite easy? So we can make any number from it very easily, very easily, okay? Now take one more number which is more bigger than it. Suppose we are taking 200 base 10. A decimal number 200 base 10. That is, we are not going to make it without 128 because we need to take here 128 because this is a bigger number. So we need to make a 200 by it. How can we make 200 by it? You can make it by yourself by pausing the video and lastly check the answer, okay? So I think most of you already have done it. Now I am going to do it, okay? Take 128. Now take 64 and now take 8. Add these three numbers 128, 64 and 8. Does it make a 200? Yes. So give 1 in this position, 1 in this position, 1 in this position and all the rest positions are 0. So what is the number? 1 1 0 0 1 0 0 0. 1 1 0 0 1 0 0 0 base 2. Isn't it quite easy? So this way we can convert any kind of a decimal number to a binary 1. And if the number is in 16, if the number is in not in 16, if the number is within 15, okay, if the number is within 15, we can construct it only by these 4 numbers 8 4 2 1, these last 2 numbers, by adding the whole of them, that is 8 plus 4 plus 2 plus 1 makes 15, right? So any number between 15 can be made only by these 2 numbers. Suppose we are going to make a number 9. So we need only this 8 and this 1, that is 1 0 0 1 base 2. If we want to make a number 13, we just need to take this 8, this 4 and this 1, okay? So 8, in the position of 8 we are putting a 1, in the position of 4 we are putting 1, in the position of 2 we are putting a 0 and in the position of 1 you are putting a 1. So 1 1 0 1 makes a 13. So this is very easy, and if all the positions has a bit of 1, that is 1 1 1 1, what does it mean? Obviously it makes a number 15. Okay, so it is very easy. If we are doing any number within 15, you can construct it only by 4 beats. Okay, and if much more the beats are added, the number of the decimal number will be much more bigger. Okay, and we already have done it here in this video. I think you will know, I have already explained it, and I think you guys got understand how to make it. And if you have any kind of queries, or if anything in this video you haven't understand and you want to know much more, you can comment it below so that I can more clearly answer you. Okay, and if you have any kind of topics which you want to learn from me, you also can write it in the comment section below. One more thing which I just told you in the introductory video at the first, that I want to tell you a tips today. So now it is the time for a tips. Okay, so before the tips I want to write the numbers. Okay, 128, it's 64, 32, 16, 8, 4, 2 and 1. Now here we have 8 beats, right? And if we need to add much more beats in the leftmost position, we need to add, this is, if I write the position, this is 0, 1 position, 2, 3, 4, 5, 6, 7, and if we write so on, so 2 to the power 8, just the left of this one will be 2 to the power 8, that is 256, right? 256, it is for the 8th position, and so on and so forth. Now the trick or the most interesting fact is that, first of all, add 2 plus 1, we get 3. See, the number just adjacent left to this number 2 is 4. That is, we are adding these two numbers and adding a 1 with it, we got this number. Okay, okay, try it for another one. Add 4 plus 2 plus 1, we get a 7. Add 1 with 7, we get 8. Okay, one more. Add 4, 2, 1 plus 8, we get a 15. Add 1 with 15, we get this one. Okay, one more. Okay, suppose this one. Add 32, 16, 8, 4, 2, 1. What do we get? 63. Plus 1, we get 64. Okay, so what will you think from this part, or what is the most interesting tips from this part? That if you want to know just the adjacent left one of any number, how can we make it with them? We just need to add the numbers and just add one more 1 with them. Okay, we just need to add these numbers and add one more 1 with them, and we get a 16. So in this way, if we add these numbers totally, we got a 255 plus 1, 256. So can you tell me which is the number of the 9th position from here? Very easily you can tell me. The number placed in the 9th position, which will it be? Think. Got it? It is 5, 1, 2. How I did it? Just add these all numbers. Okay? That is, we need to add the addition of this number becomes 1 less than 256 obviously, so the addition of this number will be 255 plus 256, it makes a number 511, add 1 with this number and we'll get the number just after this. Okay, so this is the trick of today's video, and I think you find this video helpful, and if you find so, please like my channel and subscribe to my channel and like my video and share this video with your friends. And if you want to know much more from me and want to know if you have any topic which you want me to make video on that, please write it in the comment section below. And okay, this is all for today's video. I think you find this video helpful, and the trick I have told at the last, I think it will be very helpful for you further. And if you have any kind of queries related to this video or any other topics in your mind, please write it in the comment section below so that I can interact with you on that. And okay, thank you so much for listening. Thank you.